I couldn't go on without interjecting some comments here. Naturally, all these symbols look pretty ugly, pretty confusing when you see them on the board or on a piece of paper or in an article or a textbook. Remember, every one of these quantities has a tangible meaning. Okay, so the better you understand uniformly accelerated motion, the better you understand how this expression works to find the velocity v2, and the better you understand how that expression then gets built into other expressions. And you also develop a real taste for just how neat it is when an analysis that looks this bad at this stage reduces down to something that looks this simple and has this simple interpretation at the end. Now, at every stage of the analysis, you should be thinking about what these things mean. I'm not going to go into a lot of detail on that here. One way to do that, of course, is to do an example, put a couple of simple but reasonable quantities on these, a couple of slopes, a couple of initial distances, and see how the numbers work out. But again, the ultimate lost for words here. The ultimate objective is to understand the symbols, understand how the symbols go together. Another important thing to do is look at the units of the symbols. Do a dimensional analysis at every step. You know, what are the dimensions of this? Well, the square root of v1 squared had better have units of velocity, which is units of distance over units of time. The 2s1g x1 naught, when you take the square root, had better have units of distance over time, and it does. S1 is unitless. It's a slope. It's a rise divided by a run, and the rise and the run are presumably going to have the same units, so that the units divide out and we end up with the unitless slope. G is in units of distance over time squared, x1 naught in units of distance, so the g x1 naught has units of distance squared over time squared, so that when you take the square root, you do get units of velocity. The units when you get down here. I had a bad moment, between videos, looking at this from the perspective, just made an ignorant mistake thinking that, wait, these things divide out because one is in the numerator and one is in the denominator, talking about the square roots, which I know isn't the case. And as soon as I looked at the expression, that resolved itself. But I had the initial impression that these two divided out, and the units of what I got here were not units of distance. And had I not had that realization, I might have gone on and actually done that and gotten myself into big trouble. So I realized that this can look pretty bad. When I was in a Physics 1 classroom, if you put something like this on the board, I'd not only be asleep, I'd probably be curled up in a fetal position under my desk. But eventually, we learn to think in these terms and to think and to see in the equations the conditions that go into the equation and the interpretations that are going to come out.